Hello everyone. So today we'll be looking at quite a involved multiplication problem of two different polynomials. So let's get started. And I think the best way to explain how this is going to work is to use an analogy of a simpler distribution problem. So let's say we had something like 3x times 5x squared plus 4. Well, we know this is a distribution problem because we have a term on the outside of the parentheses. So when we simplify this, it becomes 3x times the first term in that binomial, so 5x squared, plus 3x times the second term, 4. And these things are relatively easy to multiply out, so 3x times 5x squared, well, 3 times 5 is 15, and x times x squared is x to the third, plus 3x times 4, well, 3 times 4 is 12, and since there are no other variables, we keep the x. So this is a relatively straightforward problem that seemingly most of us know how to do. But what about when we get to stuff that's a bit more complicated, like this one? Well, we can sort of visualize it or process it in the same way we did the last one, where we're going to take this thing on the outside and distribute it with everything in the other polynomial. So I'm going to distribute this with y to the third, which gets me 3y squared minus 2y plus 3 times y to the third. Now I am going to distribute it with the negative 2y squared. So plus, again, we have 3y squared minus 2y plus 3 multiplied by a negative 2y squared. Now we want to distribute it with the y. So plus, again, 3y squared minus 2y plus 3 times just y, and plus, I'm running out of room, again with the negative 7. So 3y squared, so 3y squared minus 2y plus 3, all multiplied by 7, negative 7. Okay, now what we can do from here is, well, now it's a series of relatively simple distributing problems. So I'm going to take each term I have now and distribute the terms into the other set of parentheses. So, for example, y to the third will be distributed with 3y squared, in which we get 3y to the fifth power. Then 3y squared is distributed to the negative 2y to get negative 2y to the fourth. 3y, or y to the third, is distributed with 3 to get positive 3y to the third. Now we're going to distribute our other set. So negative 2y squared distributed with 3y squared. Well, negative 2 times 3 is negative 6. And y squared times y squared is y to the fourth. Negative 2y squared times negative 2y Negative 2 times negative 2 is a positive 4. And y times y squared is y to the third. Then negative 2y squared times 3 becomes a negative 6y squared. And we just keep on going. Y times 3y squared becomes a positive 3y cubed. Y times negative 2y is negative 2y squared. Y times 3 is positive 3y. And for the last one, negative 7 times positive 3y squared is negative 21y squared. Negative 7 times negative 2y is a positive 14y. And negative 7 times positive 3 is negative 21. Now, this next step is an optional choice. I think it's just sort of helpful. I'm going to rewrite what I have in order from the highest exponents to the least highest exponents descending. So, my highest exponent is this 3y to the fifth power. So 3y to the fifth can stay right where it is. And since there's no other terms to the fifth power, now I'm going to write all my terms to the fourth power. So negative 2 y to the fourth. And then my other term would be negative 6y to the fourth. And I believe those are the only two y to the fourth terms we have. So now I'm going to write my y to the third terms. So I have a positive 3y to the third. Then I have 4y to the third. I have another 3y to the third. And I believe that's it for my powers of 3. Now let's move on to powers of 2. I have negative 6y squared. Negative 2y squared. And then minus 21y squared. That takes care of my y squared terms. Now I'm going to write my linear terms, my regular y, which is 3y, so plus 3y, and plus 14y. And then after that, I have my minus 21, my constant term. Now the reason I do this is because it allows me to easily combine my like terms. There's no other like terms with 3y to the fifth, so that remains 3y to the fifth power. Now I want to combine negative 2y to the fourth minus 6y to the fourth. Now, remember, we're working with like addition and subtraction now, so negative 2 minus 6 is negative 8, and exponents stay the same, y to the fourth. Now let's combine my y to the thirds. 3 and 3 is 6, plus 4 is 10, so we have plus 10y to the third power. Now my y squared terms, remember to include that negative here. So negative 6 minus 2 is negative 8. Minus 21 is negative 29. And we have our y squared. 3y and 14y becomes a 17y. And we have minus 21. And since there are no more like terms, this is my final answer. 3y to the fifth power minus 8y to the fourth power plus 10y to the third power minus 29y to the second plus 17y minus 21. Sometimes these polynomial multiplication problems do become very long, but it's all about staying as organized as possible.